Hello, everyone. Today, I will talk about our journey of search improvement over time. Hopefully, this gives all of you guys a little bit of flavor about our work at Search Group. So, to get started, guess what is the percentage of Faire order volume is attributed to search? 20%, 40, or 60%? 60? Another guess? That was correct. So this basically shows you how central search is to Faire's business. So search is one of the most critical pathways for retailers to discover products and brands. And this is actually the same across the board. Think about if you go to Amazon, what do? People search. So we have services like main search results page, brand page search. We also have like multiple so-called like search meta functionalities like pre-search suggestions, type hat, and post-search suggestions that basically help the retailers to inspire and also help them navigate through the discovery journey. So this is the current search system architecture that we have at Faire today. If a user or retailer issue a query, it will go through like multiple key components, including query understanding, retrieval ranking, post-ranking re-ranking, and whole page optimization with UI UX. Right. So next, I will talk about a few work streams in search, retrieval, and ranking, just to showcase a little bit. So a few years back, we started to work on the semantic-based retrieval on text encoder. And the main motivation is that we want to enable the semantics in addition to exact text match. So on the right, this is a train based on our in-house engagement data to connect query versus product. So after we enable the encoder for text, we didn't stop there. We trained a model with multimodality. At the time, the state of art was clip. So the figure here basically shows a high-level overview about how we train a model with clip, where we're able to incorporate the product image as part of the retrieval process. So that, for example, if a user have a query against a static information for apparel, then we should be able to retrieve the most relevant products. So both of the efforts for text and multimodality image yield significant lift for the conversion, therefore better experience for the retailers. So far, we talked about the semantic relevance. And in addition to relevance, personalization actually plays a very important role for retrieval and ranking. So in here, we incorporate personalization tower in our retrieval strategy so that we can combine both relevance as well as personalization retrieval, as well as personalization in the retrieval. And so far, the QRP or personalized retrieval source is the most powerful retrieval source in our tech stack. In addition to that, we also have the graph learning-based retrieval source that enable us to go way beyond row-level data to extract more juice and also understand the data, more complicated data structure. In later talks, Lee, Quentin, and Wayne will touch base in more detail about graph learning as well as relevance work, leveraging large language models. Now let's talk about the ranker, right? So our ranker is a deep learning ranker called Deep and Cross Neural Network, which is a pretty popular choice across the industry. And it has many features, including dense feature, pre-training embeddings, as well as near real-time features that process hundreds of millions of data points. Some of the interesting work, just to give a few examples, the team has been working recently, includes sequential modeling, native ID embedding trained together with the entire model architecture, position debiasing, as well as device debiasing, etc. So in the era of large language model, one natural question is whether search or recommendation team can actually leverage anything from it, right? So one nice property of large language model is the so-called scaling law, as I show you on the bottom right of the graph, where the model performance actually scales up as we dump more data and more computing resource into it. It turns out that search is at the frontier, leveraging the state-of-art large language model architecture at scale, right? So this is applicable not only at Faire, across the industry. So for example, one of the directions that we're exploring today is that can we have only one model that replaces the traditional cascading architecture and combine indexing, query understanding, retrieval, and ranking all together in a single model so that we can actually optimize the entire system from end to end without like any human heuristics that is inefficient in the current system. So some of the research says it is so-called RAG 2.0, where you don't need to have retrieval and generation, you only need one model. So the goal of our future work is to go way beyond search, the traditional search, and build the next generation of search experience. I'll give you a few examples, right? How do we handle business intelligence type of queries that just cannot be handled in any other platforms today, to our knowledge? For example, help me find the trending kitchen stuffs in my area. In order to serve this query, you need to understand a few things, right? What does trending mean? What does in my area mean? Right? You need to understand where the user is at, and you need to have your own definition of the area in this case. How do we actually understand complex and conceptual queries like Mother's Day, right? And help the retailers to inspire their some ideas, but also help them to narrow down and find the relevant products and brands. Given our like B2B business slash platform, can we build an agentic system to help retailers plan their buying journey so that we can meet their budget and some of the requirements from the brands, like minimum order? How can we have the right algo-driven UI UX so that we can present the products and brands to the retailers in an intuitive way so that they can consume it, but also be able to convert on that. So hopefully through those kind of fun and challenging work, we can build a world-class AI system that is informative, natural, interactive, agent, agentic, and intuitive. So next, I will pass to Hongshen, who will talk about large language model opportunities to help co-start and personalization at Faire. Thank you.
Hello, everyone. This is Hoxin. I'm the data scientist in Discovery. Today, I'm going to talk about the large language model opportunities at Faire with a focus on co-start and personalization. So first, we know that everyone is doing large language model nowadays, but why work on large language model at Faire? For me, there are three key reasons. One is that it makes economical sense, because we know that large language models are much more expensive than traditional deep learning and ML models. So deploying that needs to have the ROI. And in Faire, because we serve retailers and they can easily spend tens of thousands, if not millions of dollars on the Faire. So that makes total sense for us to deploy LLM aggressively in whichever place that will be helpful. And the second is that the buying decision at Faire is much more complex. If you are a consumer, when you go Amazon or Instagram, you don't want the chat box to stand in between you and the products you want to explore. But it's different at Faire because retailer doesn't just want to buy for them, for their preferences. They need to buy product that would actually sell to their customers. So they really need to know more about the analytics and stats of that products, and also needs to manage a lot of things like shipping, the brand minimums, and all this communication with the brands. And the third is that we actually know a lot more about our retailers than other e-commerce websites. Thinking about that, you really don't want Amazon to know that all the things you are buying everywhere, and also all the things you have in your house, right? And imagine how much personalization they will be able to do with that. But with Faire, the retailers actually want to give us those data. So that's the point of sale data. They are really integrating that with us so we can serve them even better. So let's focus on the first problem, the cold start. So why cold start is important at Faire? Because we are trying to change the retailer behavior. Prior to Faire, they used to buy things in the physical world, and they really go to the trade shows and do things there. What we need to do is very quickly to show them that Faire is a better place to buy. And we do have the products they want. So how do we do that? So like traditional cold start problem, one aspect is to bootstrap the new retailer better, and that is by finding retailers that are similar to you. And the second is to provide targeted recommendation so they really quickly see that Faire do have the products they want. So this is a simple diagram for how we can do retailer clustering and making prediction toward that. So the first step is the box on the top left. So it's like we can use the content features and buying features to do retailer clustering, so the cluster properly reflects the user's purchase preferences. And the second thing is that we can use LLM to generate summaries or signature for that cluster. And then when the new retailer comes in, we can have the LLM to also do a similar annotation to the retailers and predict that into the cluster. And the other piece is the targeted recommendation. So in this case, think about agent is acting like an assistant for you. So it's not like building a different model, but it's more like you have an assistant go to read your profiles and understand what are the things you want to buy at this moment. And then the agent can actually go calling all these search and recommendation API and do a necessary filter and curation for you before showing you very customized recommendations. The next I'm going to talk about personalization, but not personalization in the classic sense, but what are the unique personalization opportunities at Faire, especially what the point of sale data enable us to do. A quick recap on what is the point of sale data, so which is essentially the retailer's whole catalog, their inventory, and all the transactions they have with their customers. So what can we do with that? So the first is brand consolidation, which means that how can we have retailers to buy more brands from Faire? So it is not just good for Faire, it is extremely valuable for retailer because Faire provides them with this unified management platform for their orders. Thinking about if you need to buy hundreds of products and maybe 50 plus brands every month, every quarter, and you have to talk to all these brands through their website, maybe making a phone call, sending them emails, and figuring out what is a shipping day and where things are with all these 50 brands is a crazy amount of work, and people don't want to do that. But Faire provides a unified platform to enable this. And that's why we have a huge motivation for them to actually buy more things on Faire. So the technical challenge for doing that is the entity resolution. We need to really understand the product and brand in their catalog and know how that map to Faire. And even for product and brands that are not on Faire, we need to model them and so that we can grow our marketplace to include them in the future. No need to read that diagram, just a way to show it's a very complex problem, actually. The next opportunity is the AI business coach. So at Faire, the success doesn't just mean you buy more things from Faire. We also want you to actually be able to sell those products better so your business will grow and Faire will grow with you, right? So one key challenge we learned from the retailer is that a lot of them are not technical. sometimes they really struggle to even understand what are their monthly spending on different things and what are the product and brand that work well for them versus not. So the clear opportunity here is to actually build this AI business coach as a more like a way to democratize this retailer consulting for them to help them do their business better. And this is a rough demo for that, and you can see that we can show them the data, the dashboard we created from their POS data. It's kind of like spending app for them, and also highlight the key insights. And this is pretty doable because nowadays we can have the agent to actually run code to answer a lot of business questions. So going to the future, so now we already see that one key way of using LLM is to use that to generate content features. But the more interesting future step is how to do that in reverse. Because we know the ML and DL model are able to learn information or implicit rules from like millions of training data or billions of training data. How do we convert these to a natural language that can be also leveraged by LLM, right? And when we can do both of those well, we can deploy proper agents across the user journey to help them in every step possible. So next, I'm going to hand off to Kevin and Juno to talk about the homepage.
Thank you, Hoshin. Good evening, everyone. My name is Juno, and I'm a backend engineer on the Inspire team. So our team actually focuses on building powerful recommendation systems, which will help us create personalized, responsive, and engaging homepage experience for our retailers. So the current homepage actually consists of carousels and banners. The top of homepage serves as a reminder for retailers to jump back in, while the bottom features personalized content refreshed through offline jobs. And of course, And of course, this type of homepage has certain limitations. First of all, updating the content requires us to make changes to each retrieval and ranking steps. And second, adding new types of content is costly, especially for those search-based carousels, because each individual search has to be run in sequence. And last, carousels are only refreshed every 12 hours for actively returning retailers, which means for the majority of the retailers, they only see refreshed content on the next day. So now the question is, can we generate homepage content in real time without sacrificing personalization or performance? And the short answer is yes. Introducing the home feed, which takes into account mobile users' vertical scrolling behavior so that they see a lot of content at their most comfortable pace. We're also planning to reduce the number of carousels and banners below the recently viewed carousel to focus on products from a single targeted search with multiple retrievals and rankings all run in parallel. And these are not just randomly selected products. They are carefully selected to align with what retailers are most likely to be interested in. So we actually put ourselves into retailers' shoes and came up with a list of requirements for the new home feed. First of all, a mix of content is very crucial because we have to keep them engaged so that they scroll down the page and add more products to the carts and eventually place more orders, because that's where our GMVs come from. Such things include short-term preferences, their most recent browsing history and interest, because they show us their interest at that exact moment. Long-term preferences are also very important because we use that to build a retailer profile. And then personalization is very crucial, but personalization isn't just about retailer previous engagements, because we have to predict what they might like in the future. Last but not least, retailers love surprises. We need to show them trending products, things that are popular within other retailers, and things they might have already missed. So within 2 weeks, we launched the first version of Home Feed, which is milestone 1.1. And the content consists of real-time generated content, which are visually similar products, based on their most recent product clicks, plus offline generated popular products that are coming from their top categories. We also updated the format of the feed from carousels to a long scrollable grid of products. So let's go to the next slide for some early results. We've seen 16% increase in non-restock add to carts below the fold, and 1.5 times increase in below the fold impressions. So this has been a big win, but we also look forward to more retrievals, each serving different purposes. And all this rely on many different reusable and customizable search retrievals. And to understand that system, and more importantly, how do we maintain a system that allows for simple and sustainable changes to these recommendation searches, we need to first dive into the infrastructure powering it. So now I'm going to pass over to Kevin to talk about the magic behind it, the configurable search.
Thank you, Juno. My name is Kevin Aloisi. I work on the Discovery Infrastructure team. Oops, sorry. And so we previously learned that the new home feed is going to be powered by these 5 different retrieval algorithms. Each one of these algorithms is meant to use real-time features to fetch a diverse set of candidates. But if we zoom out, what we see is that we actually have over 25 retrieval algorithms in our system. These retrieval algorithms are actually used across 15 different surfaces. So while usability adds flexibility, it also creates a complex web of dependencies between the algorithms and the surfaces they're powered on. The infrastructure, as you heard, is actually built on a parallel retrieval infrastructure. So we run these retrievals in parallel, blend the results, and run them through our first and second pass ranking, which is used to score and tune the results back to the user. But you might be wondering, with all these moving parts, how do you manage the complexity? So we addressed the challenge by structuring our infrastructure into 3 clear layers. At the bottom, we're focused on algorithmic APIs. These are functional programming that's targeted on specific APIs. These are retrieval sources, first pass, second pass rankers, maybe it's the auction, bidder, slotting. These are owned by our data scientists. The second layer is the layer that my team owns. It's the infrastructure. It's the execution, right? And we're responsible for the threading, the parallelization, the tracking, impressions, bids, all that kind of stuff that you need in order to maintain a stable system. And finally, at the top, we built a declarative language to define these surfaces. So each surface has its own customizations. It defines which retrieval sources it's going to use, which rankers, blending algorithms, and anything you want to customize for that specific user experience. To do this, we leverage Kotlin's domain-specific languages, which allows us to build a declarative language that represents the logic. So I'm going to walk you through how Juno's team might assemble a new surface. In this case, the red defines that we're going to add a retrieval source. The green defines the algorithm that they're going to include. But because the DSL supports this, we can actually provide customizations in line. So the blue might be overrides or thresholds, anything that the algorithm owner wants to enable. And so this would be to customize the experience for this specific surface. If we continue along the way, the team can then apply blending algorithms, apply our first and second pass rankers. Moreover, we can even apply our A/B testing right in the configuration. And so this creates a single source of truth that defines everything that happens on this specific surface. And this is really critical because it becomes the shared interface between the data scientists that own the algorithms and the teams producing them. So if we kind of reiterate what the outcomes are, at the top, number 1, we have now our product owners can quickly customize discovery experiences for their different use cases. In the middle, we have an use case agnostic discovery infrastructure that can focus on latency and stability of the platform. Meanwhile, the data scientists can integrate on their algorithms, knowing exactly who's using what. And next steps, we want to kind of leave you, Juno and I want to kind of leave you with some future future things. We're going to continue to increase the real-time feedback loop. That's something that everyone wants to do. But what's really exciting is all the talks about the LLM models and how we can use that in the future to dynamically determine page content. Thank you, and I'm going to hand it off to Lee to talk about our GNN-powered personalization.
Hi, everyone. I'm Lee. I'm a data scientist on the search team. On the search and personalization team, we constantly ask ourselves the question, how do we surface the most interesting and relevant product to each retailer? So this brings me to my topic today, using graph neural network to power personalized retrieval recommendation at Faire. In this presentation, I will talk about what is Faire's recommendation problem, how we formulate the problem within the framework of graph neural network, followed by some modeling detail. And I will leave you with impact and learnings. In a Faire marketplace, we have more than 3 million retailers, 150K brands, and 20 million products. As you can imagine, there could be so many combinations. So it becomes really imperative for our team to surface the most personalized product so that retailers can find their time on the platform valuable. We do have the traditional multi-towel embedding retrieval in our system. They're really powerful. However, at the same time, they're heavily based on recent engagement. As we train the embedding daily, that leads to unstable embedding. And the model architecture itself lacks the ability to model indirect relationship. At Faire, retailers cross-engage with products on a daily basis, and this naturally forms a really rich engagement bipartite graph for us to mine. So what we did is we turned the engagement logs into structured signals. We regard retailer and product as nodes with features. Retailer features including store types and other metadata, and product features including product description, attributes, brand, and categories. These nodes are connected by engagement edges. The edges are weighted by the strength of the engagement, so orders are weighted more than clicks and carts. For each node, we sample about 50 one-hop neighbors for efficiency. Given this formulation, we're able to turn the engagement logs into structured signals that we can fit into the GNN architecture. For each node, not only do they have their own features, there are also information pathways from their direct neighbors. We still impose a two-tower structure design. The retailer embeddings and the product embeddings are learned in separate towers. From the bottom up, inputs are pre-trained text embeddings from the aforementioned features, store types for retailers, descriptions for products, etc. We also add ID embedding for each items within the entity group. Those are randomly initialized, fully trainable embeddings that can expand the model's capacity to learn. These features are refined through graph attention network first. The GAT convolutional layers essentially calculate the target node's feature as a weighted average of itself and its neighbors. The weights are attention coefficient learned through the transformer architecture. The features are further massaged through MLP layers into their final embedding space. Training uses both in-batch negative as well as global negatives for more robust contrastive learning. We use different optimizers for various parts of the model parameters. In iteration, we realized that ID embeddings has very different optimization dynamics from the MLP and GNN layers. ID embeddings are sparse, they are high dimensional, and MLP and GNN layers are dense. Separating the optimizer helps greatly with model convergence. We also use time decay edge loss to put more emphasis on recent engagement. As I summarize the architecture, I wanted to highlight that the learning was definitely not linear. We started with SageConf baseline, which is a simpler GNN models, and that yields very negative early result. Then we moved to the GAT attention network without ID embedding. This brings us closer to our multi-tower baseline, but we still have some distance to go. It was adding the ID embedding, adding separate optimizers, and adding recency awareness to our loss function that finally brings us to the champion model. For offline evaluation, we see about 26% recall at lower K and 15% recall at 100. We put the model in A/B testing in our category navigation surface, and we are able to see most of the double-digit recall retained. On top of that, we see about 4.8% total order incremental increase. So what does that mean for retailers? Here's an example. This is the discovery page of crafts and hobbies for a clothing-focused retailer. Even though crafts is outside of the normal categories that this retailer engage with, GNN Source is able to step in and retrieve personalized and relevant crafts products. This means that the retailer discovery becomes more informed and more interesting. We collected so many learnings along the way of deploying GNN. Recency matters. The time decay edge loss was the most impactful changes that we added, and showing the importance of recency in e-commerce. Using different optimizer for various parts of the model stabilized training and improved conversions. And even though the ranker is trained with multi-tower features thus favor multi-tower products, GNN is ranker bias resilient. It still disproportionately impacted impression and orders. For future direction, we want to expand beyond the one-hop receptive field so that we can further unlock hidden retailer interest. We want to incorporate the GNN similarity feature into the downstream rankers to promote closer retrieval and ranking alignment. And last but not least, we want to extend the graph to new nodes such as taxonomy and brands so that more Faire surfaces can benefit from it. That leads to the end of my presentation, and happy to talk about it more later. I'll hand it over to Brian.
Cool. Thanks, Lee. Hey, everyone. I'm Brian. I am a staff data scientist, and I'm also the tech lead manager for the ads group. Just to give you some context on ads and what they are at Faire, currently ads show up mainly in our search results. So everything that Jason talked about and all the rich models we have there, we are kind of interspersed in that same UI, right? And so if you search on Faire, you'll see some of these ads. They have specific slots associated to them with this little promoted tile on them. These are for brands who specifically want to pay to advertise their products on searches where they wouldn't normally show up in organic search results, right? And so we bill on a cost per click model. In other words, if the retailer clicks, we bill the brand. And success usually for brands is anchored on what is called target cost per action, or TCPA we'll call it. What that really means is for every dollar they put in, they want to know how many conversions and transactions they get out of it. A little bit about the team. The team is really young. It's actually a really exciting time to be on the ads team at Faire. That's because we're only 2 years old. We only recently scaled the program to all US brands about a year ago. We're already at over 10% of Faire's contribution profit, and there's so much headroom in terms of just optimization of the existing models, as well as expansion opportunities on other surfaces and places to show ads on the site. One more thing I'll say is that if you're not really familiar with ads or how they work specifically, they have a lot of overlap with a lot of what I would say are search recommendation and discovery problems, right? You have this rich world of just retrieval. How do we source the best ads candidates for given search requests? Ranking is a really interesting multi-objective kind of problem. How do we trade off advertiser value with Faire value, and how do we translate these dollars to one another? There's also ad-specific problems that are really interesting. There's auction design. Do we go with first price, second price, VCG? How do we slot ads and decide when to show them versus not? And many, many more. And so there are plenty of questions you could ask yourself when you're designing an ad system. The first that we go with is, what do advertisers pay, right? And so if we want them to pay by a click, but they have a target in mind for a given acquisition cost, then we can kind of auto bid for them and set bids for them, right? And the way you can set a naive bid is you can look at this expected value of what we would call a click, right? And that you could break down into basically the probability of conversion given they click times the expected value of that conversion. And we call these different things. The first one is what we call PCTO, or the probability of click to order. And the second is what we call TCPA. The first is an ML model with a calibration layer. It has all the interesting applications and caveats that come with all of the other machine learning problems we have at Faire. And the TCPA is really based on kind of an internal target with guardrails. There are many other use cases this could be used for that we'll get into a bit later. But before, we have to figure out how we actually rank these things, right? So we basically want to rank such that if you have a higher bid, you're more likely to be ranked higher, right, if you're paying more. And for this, we deviate, or we derive what's called an auction score. An auction score is basically saying, what's the probability or PCTR that you click, given you've seen an impression, right, times the bid, if they're paying a bid per click, right? And so now we have this full breakdown. We have this like really interesting set of models that interact with each other, and we have to calibrate and tune and optimize, just like we do for all machine learning problems here at Faire. And then we have this TCPA lever, right? The first two, I think, more classical machine learning problems. The third, actually really interesting in how we might use this. And so there are plenty of ways you can use this actually for pacing. So if you think about it, really what's happening is that if you have a very high converting brand for a given search request, you are going to just keep on showing that brand in that search request indefinitely because it will lead to a conversion. For ads, brands have a specific budget that they want to spend, right? So we can only show it so many times until they run out of budget. And what that means is we actually just want to show it as efficiently as possible such that they have the lowest TCPA. In other words, we want brands to get the best price in order to spend all their budget. And so that turns into a really interesting optimization problem, right? And so the way you can use this is you can kind of plan ahead. The way you plan ahead is you can say, okay, if my brand has, say, like $1,000 they want to spend in September, how do I plan out in the month how I want to spend that $1,000? There's weekly seasonality, there's monthly seasonality, so we can forecast out the month and have a plan of spend. And then it's a matter of how I pace that spend based on the TCPA I set, right? If I have to pace it really fast because there's a lot of budget to spend, then we have to up that TCPA according to plan. But if the brand doesn't have a hard time converting and getting a lot of spend out, we can lower their price, right? And what this means is that you can build a controller-like system. Basically, you spend on a given day. If you're above plan, you can nudge down the TCPA. If you're below plan, you can nudge it up. And this is kind of how prices work out in the marketplace, such that everyone gets the best price possible for full budget utilization. These are just scratching the surface of some interesting problems, I'd say, that we have on the ads team. Again, the interesting problems abound, from retrieval and targeting, prediction, ranking, to ad-specific ones like auction and bidding. We have plenty of foundational problems like budget planning and pacing, as well as advertiser optimization on the other side. So this is just a glimpse into the kind of problems we deal with. And then, as if that wasn't enough, even if we just optimize on existing surfaces, there's plenty of problems to deal with. There are even more opportunities in the expansion realm that we have, right? We can expand to additional surfaces on Faire, which we plan to do on the homepage feed that was just presented by Juno and Kevin, which is really exciting. We have new geos to expand to. We're only in the US right now, and so Europe and Canada are upcoming in 2026. And then third, and possibly most exciting, is what we call offsite ads. So a lot of brands will spend money already on third-party platforms such as Instagram, TikTok, et cetera. They're not quite sure how to spend it or how to set targets. Because we actually have internal first-party conversion data, which is something that a lot of ads platforms dream of having, we can actually allocate that budget for them. And so that opens up a huge amount of budget where we can actually bid and set targets and manage campaigns on their behalf. So that's also really interesting. It's something we're exploring in 2026. I'll stop talking now about how much I love ads in this system. I'll leave it for afterwards if you want to talk to me, and I will hand it off to Manoj.
Hey everybody, my name is Manoj and I'm part of the AI platform team at Faire. I've been told that I'm quite tall and that my head blocks the screen, so if you guys can't see the screen, just let me know and I'll move over to the side. So today I'm going to talk about what we call the hidden engine, essentially talking about our ML infra and give you some examples of challenges that we've been facing with respect to speed, scale, and stability. Before we go into it, I'll talk a little bit about what our stack looks like, just to provide some context here. So on the online side, we are pretty much completely an AWS shop. We use SageMaker for inference. We have our own inference service, our own in-house feature store as well. And we use Kinesis and Kafka for logging, and this forms the basis of generating training data, which we then use offline to train all of our models. And in the offline world, we use Snowflake, and we use UDFs to keep online and offline in sync. So that said, we'll talk about the first challenge, which is feature logging at scale at low cost. So to give you a brief overview of what the problem is, one of our biggest challenges is that we have incredibly high logging volume. For every request that comes in, not only do we score tons of models, for each of these models, we're scoring thousands of candidates, and for each of these candidates, we're scoring thousands of features. What this results in is an explosion of data, and I'd like to go around the room just to see if anybody has any guesses as to how many rows we log on Snowflake annually. Ballpark. Are we talking millions, billions, trillions? I'll give you the answer. We log over 2 trillion rows in Snowflake annually. And yes, that's a really large number, right? So obviously, this is not something that's scalable. It's not something that's feasible. Something had to be done about it. So what we decided to do is, instead of getting our online infrastructure to do the heavy lifting, we decided to only log the core set of identifiers needed to generate the values of all of these features offline with point-in-time consistency, right? So this actually gave us a huge unlock, and it means that you can add thousands of features tomorrow with almost no impact to online serving cost. And by leveraging our offline feature store and timestamps and a whole bunch of offline feature generation infrastructure, we've been able to get past this bottleneck pretty successfully. The next thing that I'm going to talk about is feature consistency. I think we can all agree that one of the sacred rules of feature engineering is that computed features must always remain consistent. And this is easier said than done, especially when you have features that are reused by multiple teams, and it's very easy for somebody to make a change to a feature, which then causes silent failures downstream in models in production. I'm sure pretty much everybody here has faced these types of problems before. The other sort of sacred rule that we must respect is that features must remain in sync online versus offline. Otherwise, you end up with training serving skew. Now, taking this example that I'm showing on screen here, a simple change to a pretty commonly used feature here can cause a lot of issues for models downstream unless we handle this properly. The way we decided to handle this was by using TensorFlow, and not in the way that you think. We don't use TensorFlow for model serving, but instead just use its statically computed DAG capabilities to allow us to version features. Now, the reason why this is so powerful is twofold. First reason is that consistency is guaranteed. You're pretty much baking a feature into a protobuf, which is then stored as an artifact on S3, and it's immutable. The second part, and the more important part, is that it gives us interoperability between our offline compute, which is completely based on Python, and our online inference setup, which is based on Kotlin. So protobufs are a really nice way, and they serve as a nice interface for offline and online to remain in sync. After these changes are done, this is what our stack looks like, and we can now use protobufs as a single source of truth between offline and online environments. The third challenge that I'll talk about is that of our unstable GPU cluster. Now, when we initially set up our GPU cluster at Faire, we had a handful of users, so we didn't need to over-engineer it. But quickly, as Tuan was talking about before, we've had breakneck growth, and what this meant was this resulted in a Wild West kind of situation with everybody having bare metal access, SSHing into GPU boxes, no failure isolation, single bad job takes down the entire cluster. We reached a point where we had numerous incidents because of this, and this was actually significantly impacting velocity for multiple teams across the company. The way we decided to solve this was to, first off, change our compute layer to move to Kubernetes. This allowed us to have better scalability and more elasticity in workloads. And we also went with a very common software tool called RunAI, which allowed us to containerize workloads, get failure isolation, and more importantly, I think both from the end user perspective as well as the cluster manager's perspective, I think it made life a lot simpler and much more stable. So this was a big hit, and all of our workloads run on RunAI today. So we spoke about the challenges. I'll also spend a minute talking about what the future looks like. Starting at the most bleeding edge, on the agentic side, you've heard people talk about some of the agentic efforts that are going on, and AI platform sort of lies directly in the crosshairs of a lot of these efforts. It's very nascent and fluid. So what that means is that there are a lot of opportunities in this space. We have a lot of interesting things we're working on, so please come work for us. And a lot of these challenges are both internal facing as well as external facing. External facing in the sense that you heard Hoshin talk about some of the customer facing agents that we're building, and internal facing in the sense that there's a lot of scope for us to leverage a lot of these AI coding tools to improve developer productivity within the company, and there are a lot of ongoing efforts in this space. Moving a little more to the mid-spectrum, talking about some of our LLM efforts, we're already investing a lot of time and effort to replace our existing LLM gateway to level it up, because there are many more teams within the company that are using LLMs, so we're looking to centralize everything into a single gateway and ensure that all customer-facing LLM workloads are productionized and set up properly, and also adding support for MCP servers as we do that. And last but not the least, and this really is our bread and butter because it drives the most revenue, these are our DL models. And one of the main areas for investment for us going forward is to dramatically speed up training jobs by looking at all layers of the stack. So we're talking super low level, working on hardware level, acceleration improvements, RDMA, moving all the way up the stack to changing torch code to improve GPU efficiency. Tons of interesting problems. I'll be around, happy to chat with folks who are interested. Thank you, and with that, I'll hand it over to Quentin and Wayne.
Hello, everyone. I'm Wayne Zhang, Principal Data Scientist working on AI and ML at Faire. Very glad to share some of the work that we've done on fine-tuning large language models, and also some of the use cases at Faire here, where we've seen real business impact. So why fine-tuning large language models? A common way to use a large language model is through prompt engineering. You can also include a few examples to better guide the model behavior. This is called few shots. Oftentimes, the model works pretty well. This is all you need. But in some very complex applications or business critical tasks, which demand very high accuracy, this may not be sufficient. This is when we should consider LLM fine-tuning. So fine-tuning means continuing the large language model training on specific tasks using labeled data, so that the model can learn from more complex patterns and the performance improves. In lots of these cases, you don't need big models. Instead of like a 200 billion parameter model, sometimes a 7 billion, 12 billion model will be sufficient. So small models are much easier and faster to serve and train. The trade-off, however, is that it requires more investment in model development and deployment. Here are some example tasks at Faire that where fine-tuning has worked really well. The first one is deciding whether a product is relevant to a user's search query. At Faire, we have our own definition of search relevance, which Quentin will talk about later. Second is identifying the type of the product based on the product description or images. At Faire, we have thousands of product types with our own definition. The last one is generating a short product title based on the image following our internal guidelines. So in order to support fine-tuning at Faire, we have built our own infrastructure. Of course, there's lots of third-party solutions out there. If you just get started, you don't have to build things in-house. But what we have found is an in-house solution is much more cost-effective and flexible. One of the main reasons is we already have a dedicated GPU cluster, which we use for standard deep learning training. So this cluster now is shared for the LLM training and batch inference. We also build a custom Python package that takes a standard fine-tuning data format and automates the training by implementing some of the advanced training methods. For real-time solutions, we still use a third-party solution. So in order to be able to fine-tune the models efficiently, we adopt several technologies here. We use a LoRa adapter, which allows to train just a small percentage of the full parameters. We use deep speed, which allows us to split the model parameters across different GPUs for distributed computing. We use quantization to reduce the model size. We use mixed precision training, gradient checkpointing, gradient accumulation to save GPU memory and speed up training. So this is a very high-level overview of our fine-tuning infrastructure. Now we're going to talk about two use cases where we see fine-tuning has driven real business impact. So now I'll turn over to Quentin to talk about search relevance.
Yeah. Hello. Cool. Hey all, my name is Quentin. I am a data scientist on the search team. So I wanted to talk through a practical end-to-end application where we used fine-tuned LLMs to make our search stack aware of relevance. So relevance is highly important. If we show too much irrelevant results, we would make it very difficult for retailers to find what they need. For example, when I was testing this like 2 years ago, and when we searched for a water bottle, we were returning lip balms, and even like I was losing trust in the platform. So yeah, super important for us to reduce the number of irrelevant results that we see. Most of our models, however, like in ranking, retrieval, use engagement, such as clicks and orders, in order to, as like the optimization. But engagement on Faire is not the same as relevance because retailers have a much broader sense of shopping than a normal consumer. So they will be like curating their store, they might be searching for a lot of different things at once and be more willing to engage in irrelevant items that are inspiring for them. So we needed some way for us to really understand the natural language of a query as well as a product and understand that semantic relevance, which is something LLMs are really good at. To begin, I mean, defining relevance, it seems easy at first, but it's actually a really, really complicated or nuanced subjective area. But for the purpose of this talk, we simplified this down to a multi-class classification problem where we put everything within exacts, substitutes, complements, or irrelevant. We iterated on guidelines for quite a bit, and we're able to produce maybe like a small set of high-quality labels, which we used to build all of our models with. To begin with, we tried something quick where we tried to do prompt engineering and zero shot with what was available at the time, but really weren't able to reach good performance. And we really needed to fine tune in order for the LLMs to understand our definition of relevance. So currently in production, what we have is kind of two layers. We first have a teacher model, which is a fine-tuned Llama 3 model. It's actually just a $8 billion, not $8 billion, but 8 billion parameter model. Fine-tuned using some of the techniques that Wayne had mentioned. But in addition, we also explored curriculum learning with the limited amount of data that we had, self-learning, and also adding other stuff such as our brand awareness models. We were able to achieve a pretty good accuracy for such a nuanced problem, which is 86%. This powers a lot of our measurement on a platform, including like measuring whether an XP is increasing or decreasing relevance. But this was, I guess, like not fast enough for us to meet the latency constraints that we have for search. So we needed to distill this into a smaller 2-tower model, which we then use for a lot of applications. So as a signal, one of the things that we did first was to blend this relevance score with the engagement-aware ranking model. And by doing this, we're able to immediately make our results more relevant. And this was very helpful for new retailers because their personalization signal was more poor without a lot of engagement. They were seeing more irrelevant things, and we saw like 10% increase in orders from these new retailers. The problem is that like we can't just completely remove all things that are irrelevant because of the unique nature of the Faire platform. They need to be inspired when they're in an explorer mindset. And so we tested a UX application where we basically like sucked up all the irrelevant items from the first page and then put them into a little carousel. So we had a balance between relevant search results as well as a launch off point for them to explore more relevant other ideas that they were looking for. More recently, after we migrated to a deep learning ranker, we're also able to do multitask learning. And so we added relevance as one of the objectives, and we're able to really decrease egregious cases of irrelevance. So I'll hand it back to Wayne for one more application.
Thanks, Quentin. So another important application is product type classification, or we call taxonomy classification. So on Faire, every new product must be assigned to one of more than 3,000 Faire-specific product types. So this process used to be very time-consuming and error-prone. Users generally spend more than 15 of their time in onboarding to select the product type. Even with that, over 20% of the products were tagged incorrectly, which meant that millions of products had to be manually fixed by our ops team. In order to solve this, we fine-tuned an open-source vision language model called Lava that allowed us to use both text and visual signals here. In this application, images are really important because some of the product types definition really depend on the design and the patterns from the images. So with this, we were able to achieve over 95% accuracy compared to only 70% accuracy from our previous models. This is on par or even higher than human accuracy. So the business impact is very clear. Onboarding is much faster, operation cost is much lower, and discovery is more accurate. So to summarize this, we find that fine-tuning LLMs is really important for business-critical tasks. Oftentimes, small models are sufficient, which saves cost and improves speed. However, this needs to be balanced with more development cost, but we think the benefits are worth it. Across Faire, we've seen strong results from many applications of fine-tuned LLMs. We just shared 2 of those use cases here. Large language models is really transforming the e-commerce industry. So at Faire, we are building the infrastructure to support large language model development and applying large language models to problems like ranking or agent applications. We are very excited about the future of AI at Faire. So we invite you guys to join us and building this together. Thank you, guys. With that, I'll turn over to Yuanqi to wrap it up.
Thank you, Wayne and Quentin. That wraps off all our 7 tech talks. I hope that 7 tech talks are a lot of great content for you folks to enjoy. And believe me, the 7 talks are still just a glance for the work we do at Faire, and within Discovery, there are a lot more interesting things this org and this company is tackling. We will actually also have more this kind of tech days coming up at Faire. So stay tuned. Please also follow us on LinkedIn if you are interested in future Tech Talk events. With that, I want to also share that while we are continue tackling and transforming this wholesale industry, we also have a lot of openings that we are sincerely hoping we can connect more with our industry peers. If any of you found our problem interesting, find your domain is very relevant, you are more than happy to connect more with us. Check out these roles on our website. Follow up with the hiring managers during the mingle time and happy hour. But before I close up, I'd love to really thank everyone who helped make this event happen within Faire. It's many efforts behind the scene. So really a big shout out to Ed sitting there, Eric, our Discovery Infra Manager, folks at the back, Spencer, Emily, Tom, and folks already left, Louis, Samaj. So really hoping to see everyone again at Faire, and let's mingle. Thank you.